Hey guys, I hope things are going well. I hope everything's going okay. We're ready to get started on to this next class here. We'll try to keep this nice and sweet and straight to the point. We did talk a little bit about this in class just last time we met. But we're going to go over this and go into a little bit more detail. So we'll take a look at this. We're going to talk about air masses and fronts. Okay, so let's take a look at this. Let's see what we've got here. First, we want to talk a little bit about air masses and what an air mass is. An air mass is an area of air that migrates and moves around. Okay, it takes on the characteristics of the ground below it. So if the ground's warm, it will be warm. If it's wet, it's wet. So let's take a look at this. Here's what an air mass is. So like what we have here, you'll notice that the air mass has two characteristics. One, that it is dry, and the other one, that it is warm. So anytime we talk about air masses, we're always going to talk about two things. So when we look at this land here, we would expect the air here to be dry and warm. Let's take this other one. This one, we would expect the air to be above the water. We would expect, since it's wet underneath here, that the air would also be wet. And if it's a warm area, then we would expect the air to be warm as well. If the air was cold or the water was cold, then we would expect the air above the water to be cold as well. So let's take a look at this, a little bit more detail here. An air mass is determined by two things. One, it is determined by moisture. Okay, so is it wet? Is it dry? That's what we need to take a look at. If it's wet, if it's dry, and I put this little tiny thing in here, that sometimes it feels like this. Okay, it's not the heat, it's the humidity, and sometimes we feel like the air is so wet that actually the fish are swimming around us. You can't stay dry, you're always hot. Okay, so we look at the humidity, but we also have to look at the temperature. So is it hot or is it cold? Here's another little diagram here, okay? If it's cold, then we're going to give it one name. If it's hot, we're going to give it another name. Same with the humidity. If it's wet, we'll give it one name. And if it's dry, we'll give it another name. So there's going to be some name memorization here. But it's not that hard. It's actually pretty simple here. So either an air mass, it is either going to be dry or it's going to be wet. So let's take a look at this. Here are a few things for you to note on this. Okay, so if we have dry air here, okay, we are going to give it the name continental. Hopefully that makes sense. Continental means land, and right here I have this little C right here. That is the symbol for it. So we're going to use that symbol C to designate whether the air is dry. And all that C means is continental. Now, what if the air is wet? Well, then we're going to call that maritime. This should be a word that should make some sense. A lot of people doesn't make sense until I say like the Marines or marina. As soon as you think of those words, all of a sudden you start thinking about the ocean, and that's exactly what this means. It means that it's wet. So we're going to give wet air the name of maritime, and the symbol will be a lowercase m. Okay, so when we talk about humidity, we always start out with this symbol. Either it's going to be dry or it's going to be wet, and we either put in a lowercase c or an uppercase m. This is how we start to identify an air mass with its humidity, dry or wet. Now, when we go to temperature, we're going to add just something a little bit different. So we need to identify whether the air is cold or whether it's warm. So if the air is cold, we're going to call that polar. And polar is symbolized by a capital P. Okay, so it's symbolized by a capital P. So capital P, that means polar, it means cold air. Now we get over to here and we're going to see that we have warm air is going to be tropical, and it's symbolized by a capital T. These should make some sense here. Okay, polar should mean cold to you. Tropical should mean warm. And the symbol we're going to be using is a capital P and a capital T. And we're going to use a combination of the lowercase letters, the C or the M, along with the uppercase letter P or the T to identify an air mass. So let's take a look at this. We're going to identify some air masses here. So an air mass they are identified by the two factors. Okay, we need to look to see if they are actually what the air is. Okay, is it wet or is it dry? And is it warm or is it cold? And these are the symbols that we're going to use. Okay, so if we have wet air and it is cold, wet, if you remember, means maritime. So we use a lowercase m. And if it's warm, we use the word tropical. We're going to use the symbol capital T, which we put right here. So maritime tropical, that means that we have wet, warm air. We would find this over areas that have lots of water and probably more towards closer to the equatorial regions where the water is going to be warm and it's going to be wet. We'll find these air masses usually over the oceans or somewhere where there's a lot of water that is on the ground. Now, what if we have wet, but it's cold? Well, we're still going to use M because that identifies our humidity. It means that it's moist or it's wet. And then we're going to use the capital P to tell us that the air is cold. Where would we find air like this? Well, let's go further up north. Let's go off the coast of Alaska, where we have the Pacific Ocean and northern portion of it where the water is going to be cold. Any of you have ever been to the Northwest? Well, then you'll know when you go to the beach, the water is cold. The air is going to be cooler. It's going to be wet. By the way, this is where we get most of our winter storms, is that air comes down from the northwest and brings in that wet, cold air, and we usually end up getting our winter storms. Now, what if the air is dry? Well, then we know that we're going to say, oh, well, it's dry. So we're going to use the symbol C, which means continental. All right. And then what if it's warm? Well, then we're going to use the word tropical or the capital T. So it's going to be continental tropical. Continental means that it's probably above the land, and most land is going to be warm. Most. I think about the deserts during the day, and it's gonna be dry and warm. So somewhere like this might be maybe more like over Mexico during the summer. It could be southern Utah in the summertime, where we have dry air and it is warm. All right. What about dry cold? Okay, so if we have air that is dry and it's cold, we will use a lowercase c to say that it's dry, continental, and the uppercase P, which means polar, which means that it's going to be cold. So we have dry, cold air here. This also could be Utah air, but in the winter time as well. So when we have winter that comes around, the air typically above where we live here will be dry and cold. Now, there is one more symbol here that I did not mention earlier, but we're going to say it's very dry and very cold. And really, it's going to get its own symbol. That's an A. All that means is Arctic. Arctic air is very, very cold. And it's usually bitterly cold. Okay, and it's just me. I call this booger freezing cold. This is the kind of air that when you go outside, you think that it's okay. You're in your house. The sun's out. It feels nice inside your house. The sky is blue. It's beautiful. And then you walk outside and all of a sudden everything just freezes. Okay? Even all the moisture in your nose just freezes. And that's why I call it booger freezing cold. It is just cold. Everything freezes. And you walk out and immediately you turn around and you walk back in. Okay, it is cold. This is the kind of air that comes down from the Arctic. And if you watch the news, especially the meteorologists will probably tell you we're going to get some really cold air here. If you have small animals, then you probably want to bring them in out of the cold for the evening because they probably won't survive the night. Also, they might even tell you to turn your water on so it's dripping. That way the pipes won't freeze in your house. That's how cold it is. So we call this very dry, very cold, bitterly cold, and it's known as Arctic. Okay, so these are the 5 types of air masses that we can get. We can get maritime tropical, we can get maritime polar, we can get continental tropical, we can get continental polar, or we can get Arctic air. These are the 5 types. And by the way, Utah gets all 5 of them. Just depends on the jet stream and how that air moves, how it moves throughout that year. But typically we do get all 5. Even that Arctic air, we can get that in January and February. Just totally depends on our situation that's going on here in Utah. So let's take a look at these air masses again. Okay, so we have all of these different things. Remember how I told you like maritime tropical? Okay, maritime means that it's wet and it's warm. So look right here. We're going to probably find this right over the South Pacific, closer to the equatorial regions. You come up here and we have maritime polar. And that maritime polar, we're going to find that it is nice and cool, humid. The water's cold. The air is probably wet simply because it's above the ocean. We get down over here and we're going to find that we have the same thing. We're going to find maritime tropical. So we got warm, humid air. This would be like off of Florida. And then we get right up over here and we can get that maritime polar, which means more maybe New England, further north. We're going to get that nice cool air off the east coast of Canada. Cool wet air. And then if we go really high, more further north, up above Canada, we're going to find that continental Arctic, or that Arctic air, which is going to be bitterly cold and dry, really dry. Okay, we know that if you remember the last video you watched about pressure, that the polar cell, it drops, so we have a high pressure way up here, and that high pressure is going to bring dry air. Remember, the North Pole and the South Pole are both cold deserts. Okay, now these 2 pictures here are different. This is more of our winter time. This is more of our summertime. So how does the summer look? Well, okay, so some of this air here will start to move forward. You can see up here, it's further south. And this, now that the heat has gone up, the sun is more up in this direction here, we're going to start to see even warmer, wet air. Okay, it's going to be more warm, it's going to be more humid. This colder air, instead of dropping down in Utah, we're going to see it drop more up into Alaska and those areas. Okay, we start seeing this warm tropical air coming off of Florida. Now it's coming in with all those hurricanes. Everything starts to adjust and move around. These air masses do move around according to the cells and where that sun is heating the earth at that point in time. So an air mass moves according to the global wind systems. Now remember the last video I talked about the Hadley cell, the Ferrel cell, and the polar cell. And if that sun moves further north, well then that Hadley cell will follow it. And then if the sun moves more south, that Hadley cell will follow it. Well, those air masses will move up and down with that, which is why the last time I told you we pay attention to the jet stream. If the jet stream drops, then we know cooler air is coming down. If the jet stream moves up above where we are, then we're going to receive more warm air. Depending on where that air comes from, it could be more off of the ocean, which would bring more humidity, or it could just come up from maybe like Mexico in the summertime, and then we get that dry air that comes in. Most of you have felt that before. Okay, so we have these air masses. Now, the boundary between these air masses are called fronts. Okay, so when we have one air mass that comes in and we have another air mass, we have cold, moist air here, and maybe have warm, moist air here. When the two come in, they'll collide, and that boundary between the two, we call those fronts. And this is what you've probably heard about: cold fronts, warm fronts. There's also a stationary front and an occluded front. Let's take a look at these fronts here. So the first front we'll want to look at here is what's called a cold front. A cold front is where we have cold air and it has more energy and it moves on in. Over here we have warm air. This warm air, this cold air acts like a bulldozer. It's dense, it's going to move on in, and since that warm air is less dense, where does it go? Well, it's going to move up and over the top of this cold air. This cold air moves in, this warm air gets pushed up and over, and we're going to get what we call, we're going to get those thunderstorms. You're going to feel a change. Okay, now let's go back and take a reminder of some of the things we've learned here in the past, especially in class. If I have warm air here, you know warm air has the ability to hold more moisture. Cold air doesn't have the ability to hold a lot of water. So if I have warm air here, chances are it probably has some water in it. More water than cold air would. Now if we get that warm air to come in and to get pushed up into colder regions, then that air will condense and we'll start getting clouds. And this curvature right here is pretty steep. We can actually see this as a nice little wall, but we get this air that comes in, and as it moves up, that air will cool down, these clouds will condense and start dropping a lot of rain or snow, and we get those thunderstorms that occur. Here's an interesting thing. Some of you have actually probably witnessed this before, but if you were standing about right here and it was nice and warm, as this comes in, the one thing you're going to notice is that the wind will start picking up. And as you get closer to this point, this will end up being a low pressure area. And so that means air is rising. You remember low pressure moving up, going down is high pressure. Okay, so we've got this air, we've got low pressure, and this air starts rising up. So as you get closer to this, the front, the wind is going to start picking up. You may have even been at your house, and all of a sudden there's a slight little breeze, and then the wind really starts picking up. Maybe you have a flag outside or garbage cans or something, and you notice that they're moving around. You're getting closer and closer to that front. Now, once this front, if you're standing right here and that front moves in, okay, once that front passes you, you're going to feel an instant drop in the temperature. That temperature will drop a lot. It might drop about 10 degrees, and all of a sudden you'll be in the house, and you'll be like, whoa, man, it kind of got cold all of a sudden. Chances are a cold front came through. Now, depending on how much water is here, you may not get some of that rain, okay? If it doesn't have a lot of moisture in the air, you might just feel some wind, and then the temperature will drop. Okay, you might not get any storminess to it, but in most cases, you do. You're going to get some nice stormy clouds with a cold front. You can always tell when a cold front comes in, the temperature changes. You can see these great big clouds that start just rolling in. So you might have like clear skies over here, and then as that front comes through, look at what happens. You start billowing up all these clouds, and then you start getting more cloudiness through here. So it will be nice and warm, clear skies. The storm comes in. You can just feel like this big wall's coming in, and boom. All of a sudden, you're on the cold side. You're in a cold air mass. All right. Now, one other thing to notice here, you see this right up here? Okay. This right here is the symbol for it. So we end up with this blue line right here, and we have these triangles. These triangles here are going to tell you which direction that the wind is which direction the air is moving. So if I have a cold front, this side, on that side of it, it's going to be cold. This side is going to be warm, and that points the direction that the air is moving. So it's perpendicular to the line. So it's going to move like this. This one will move this way. This one over here will move that way. And you can actually see where that air is moving. That's the cold front. It doesn't move in a straight line. It will just kind of ooze out. Like if you put water out on the table, it will just flow out in all directions. That line right there represents that boundary where that water's flowing outward. And the arrow, or that little blue triangle, points the direction that that water is moving. But in this case, we're talking about air instead. Hopefully that kind of gives you a visual of what this looks like. So the next one we want to look at is a warm front. Well, here's a picture of a cold front. So you may have seen something like this. Okay, you see this great big wall here. What you actually see is you see more warm air over here. That warm air starts to move up and over, and we start getting all of this cloudy, stormy weather. Okay, in fact, on this side of it, where it's all nice and dark, you're probably gonna have cold air. And over here, it's gonna be cooler. I mean, because we're right there at the front. But there will be a big difference between stuff that's found over here versus stuff that's found over here. Okay, so we're gonna get a definite difference here. All right, let's go to the warm front here. So a warm front looks a little bit different. You'll notice that this is not as steep. It's more of a nice gradual wedge, where the other one was this big wall that came up. So a warm front is where we have warm air right here. It has more energy in it than the cold air, and that warm air is going to come in and it's going to push that cold air out of the way. But you got to remember, when that cold air came in, it's more dense. Therefore, you would expect that great big wall. The warm air is not going to be as dense, and so it's trying to push dense air out of the way. And so what you end up seeing is you start seeing a more gradual push. It kind of starts to flatten out, and we start seeing this nice little wedge that occurs here. This is a warm front. Now, one thing that you'll notice, I like warm fronts, because usually what happens is that you're over here and you're in the cold. Okay, all of a sudden the rain starts coming down, and as this warm front comes through, you got to remember, this is cold air, this is warm air. Notice up in the sky, there's no clouds. All the clouds are over here. So you'll be sitting there, all of these clouds, the rain comes in, and then you can actually literally see all the clouds moving away from you, and you see all the blue sky. And that blue sky comes in, the temperature increases, it gets really warm, birds start chirping. It's like, oh man, that's kind of nice. We get these a lot in the spring. This is the warm front. Now, there's some cool things about this. We get out here, and I want you to pay attention to what I have here about the different types of clouds. So way up here, this one right here, without getting my finger out of the screen here, you have those cirrus clouds. So cirrus clouds, remember, they're those horses' tails. They're kind of wispy looking. Well, okay, so if I was standing right over there and I was looking up and I could see these nice wispy clouds forming. In fact, I think I have a picture of them right here. So you see these cirrus clouds, they're forming. You can actually tell where the warm front is by looking at these clouds. Okay, if you notice, let's see, let's pick this one right here. You can see I've got this nice curl like this. Okay, they're all curling like that. Okay, well, the reason why that's curling is that the air is coming up that wedge, that slope, and it comes up, and as it goes up, it starts to curl back. It starts to curl back and curl back. Kind of like if you were, I don't know, peeling a carrot or something, and it starts peeling, and then it just starts curling as you are peeling it. I know that's dumb, but work with me here. That will peel back. Check it out. You can tell where the warm front is by following that curl right through here, and then this part right here points to the warm front. Notice which direction all of these are pointing. They're pointing this way. That means the warm front is down over here, and it's about 3 days away. So if we start seeing a lot of these clouds, chances are you're going to end up with a warm front that's coming. This usually means a storm is coming in about 3 days. So let's go back to this image that I had here before, and let's take a look. So right out here, you'll start seeing all of those cirrus clouds, and then we end up with a cirrostratus. Remember, cirro means really high, stratus. So all these wispy clouds that I showed you before, they start filling in, and they're going to get more and more and more. And you're going to start seeing that these clouds are just going to start filling up the whole sky. They'll be a little bit thinner, but they're definitely going to fill up the whole sky. And they're thin because they're really high. But as this front moves in closer, you're going to see that the clouds are going to start dropping, and that's why we get to this altostratus. So we started out with these thin clouds, and then you're going to start to see that they'll thicken up. That's because that wedge that we have right through here is getting narrower, which means the clouds can build up even higher. And then we get down here, and you notice that this is a nimbostratus. Okay, this is not a cumulonimbus. Cumulonimbus you find at the cold front and the big billowed up, great big clouds. This one is going to be more widespread. It will be thick and it will rain. But you notice the rain is not super heavy. It's not very heavy at all. After that rain comes through, this depends, of course, on the speed that this is moving through. But typically, from about here to here, you can plan 3 to 4 days. You'll have a rain coming in. After that rain passes you, boom, there you go. You got that nice, clear, warm air. Things start warming up, and it's beautiful. The symbol for this is, okay, it's a red line with semicircles, and it's all in red. So the one thing I like about this is it reminds me of a sunrise or sunset, and the red just means that it's warm. The last one, the blue line with the triangles, I think of those as icicles. So when I see blue and triangles, I think of cold icicles. This one, I think of warm sunshine that's either rising or sinking below the horizon. And the semicircles point the direction of where the warm air is going, and so we have warm air that's moving in this direction. All right, let's take a look here. We're going to skip past the cirrus clouds, and we're going to go to a stationary front. I don't like stationary fronts. I really don't. Stationary fronts, So what you can see here is we have cold air right here. We have warm air over here, and they're both just trying to hit it. They're just going head on head. Well, pushes this way, and then it pushes back, and pushes this way, pushes back, which means that the two air masses are equal, or close to equal, and they're just moving back and forth. That's why we call it stationary, because it doesn't go anywhere. It doesn't move. They just kind of just back and forth and back and forth. Okay, and you will get some storminess in there. Usually they kind of hang around for a little while. The storm will move out, and then it moves back in, and then it moves out, and then it moves in, and it might be cold, it might be warm. Can you see why I don't like stationary fronts? I just don't like them. Because they're just unpredictable. You don't know. You're out 1 hour, and it's nice and warm, and then within 15 minutes it changes to cold and wet. And then another 20 minutes, it goes back to warm and nice again. And they're just constantly moving back and forth. And usually we say, welcome to Utah, right? This is our springtime weather. Now take a look up here. Here's the symbol for it. Remember, blue triangles means cold. Red semicircles means warm. So what we can assume here, since the semicircles are going this direction, we can say that the warm air is right here. And since we know that these blue triangles are pointing down, that means that the cold air up here is moving downward. So we have warm air that's going up, we have cold air that's going down, and we end up with this stationary front. Hopefully that will make some sense. Warm air is going one way, cold air is going the other way, and they are just like pushing into each other. Okay, let's take a look at this stationary front here. seen skies like this before? Okay, just really kind of overcast, don't really do anything. It's might be warm, might be cold, might be wet, might be dry. It's usually always cloudy, not very fun. All right, here's the monster of them all. This is the last one. We're going to call this the occluded front. The occluded front is a little bit different than the other ones. So what we have is we have cold air right over here. And then I have warm air right here. But the warm air is more powerful than that cold air. So look at this. We have a warm front right here. So ignore all of this over here, and that looks just like a warm front, okay? Warm air is pushing this way, cold air is trying to move out, but the warm air overtakes the cold air, and we have this nice little warm front. But here's the kicker. Coming up behind it is a mass of cold air that comes in, and it's moving in faster than the warm air. So it comes from behind the warm air, and that warm air gets trapped between the cold and the cold. And since they're both more dense than the warm air, this cold air comes in and just bulldozes all of that warm air up. It takes all of that warm air and just pushes it all up. Not this little trickle going up, but all of it. Once we can take a massive air mass that's warm, full of moisture, and we can push that stuff way up into the sky really fast, then we have heavy rains. Okay, these are dangerous. This is where we're going to run into our tornadoes, heavy, massive rains. This is usually symbolized by, and this hopefully will make sense. Okay, we have this nice line here. You'll see that we have triangles, which means cold, and we have semicircles, which means warm. But notice the color? The color is purple. Well, what happens when you mix red and blue together? You get purple. So this means that both the warm and cold air have collided, and they're moving all in the same direction, and we end up with this occluded front. These things, if you ever watch the tornado shows, they'll be looking on the radar, and they'll be looking for this little swirl or this little tail. Because usually what I have is I have a warm front, or I have a cold front, a warm front, and a cold front, and where they all combine, there's this little loop that occurs, and it's usually all right here, and we have a super low pressure system there, and they look for that little tiny loop. Usually that's where you're going to find your tornadoes if it's the right season and the conditions are right. Let's take a look at this. There's our nice little loop. Chances are this is a super low pressure. We have cold and warm air that's combining, and this is the very tip of that tail. Look, we have massive clouds that are forming up and around this. Extreme low pressure here. This would be our occluded front. Okay, super dangerous, not very fun if you ever live in tornado country. Some of these clouds that you might find associated with this, these are some of my favorite clouds. These are called mammatus clouds. I love them. There's a lot of these undulations that come down. You can see the spiral things going on. This usually indicates that the air above is, there's a lot of turbulence going on. I've seen these before, and some say they're not associated with tornadoes, and some people say they do. I know that I've seen these when tornadoes occur, and when I've seen these, I've actually looked up in the sky and like, okay, I'm looking for a tornado, and I have seen tornadoes drop. So you decide on that. It does say this, so the air is really turbulent above. So if the conditions are right, you'll probably see these around with tornadoes. Okay, I have just some things here I want to show you. We're going to try to keep this nice and simple. So let's go ahead, and I'm going to click on this. We're going to go to this site here. Okay. And let's take a look at this. So I want to show you each one of these up close and show you what's going on. So let's show you the cold front. Do this animation here. So you can see the cold air is coming in. What happens to that warm air? That warm air gets pushed up and over the top. You can see right through here. We're going to start getting clouds to form. Water's going to start condensing out of those rain clouds, and we end up with this these nice big thunderstorms. Okay, this is the cold front. Let's take a look at a warm front here. Our warm front, okay, you notice that it's not as steep, it's a little bit more wedged, and it doesn't move as fast as maybe like a cold front, but it comes in and it's pushing things out. As that warm air starts to rise up, you're going to start forming these clouds, and I don't remember if yep, there you go. See all those nice wispy clouds? So you can see those cirrus clouds, usually a good indicator that we have. Okay, let's go to the stationary front. Stationary front here. Both come in, they collide, and you're going to see that they just kind of move back and forth, move back and forth. We're not going to get a lot of cloudiness in here, nothing super impressive. I know it shows this, but really it depends on where you're at right here and what's going on. This thing will just fight back and forth and move around. You might have rain, you might not, for whatever it's worth. Now, let's take a look at the occluded front here. Here's the occluded front. Okay, you see that the cold air is being pushed out by this warm air. This cold air is catching up to the warm air, and what happens? Right here, that warm air just starts lifting up. And so now we actually have cold air making contact with cold air, and all of that warm air has been pushed up. We have all this nice warm air that's just been pushed up all at once. Massive storms. Things change dramatically. Not very fun. Okay, I hope this helps. Tried to keep this as short as we can. Looks like I'm close to 40 minutes on this. Hang in there, okay? Study this stuff, and hopefully this helps you learn a little bit more about warm fronts, cold fronts, what a front is, and air masses. Remember to know those different types of air masses. That an air mass is divided up by its moisture content and by its temperature. And then what a front is just a boundary between the two. Okay, and depends on what air mass is stronger than the other one. And that's the type of front that we call it. Okay, I hope this works for you. I hope, like I always say, I hope I get to see you guys soon. If I don't, hopefully when you see me, you'll say hi. And I will do the same to you as well. But enjoy, take care, keep on moving on. See ya.